Okay, so having done CPD 16, this next problem is follows kind of nicely from that. So we have this result about order, and now we want to prove this fact about the relationship between the sign of the 2x2 determinant and the orientation of the ordering. Right? Okay, so let's suppose that we have that V and W are in right-hand order. Excuse me, are in counterclockwise order, sorry. Okay. All right, so now what we've concluded, what the previous exercise, CPD 16, tells us is that this means that E3, comma, V1, V2, 0, comma, W1, W2, 0 is in right-hand order. And we have a fact from this other theorem, the R3 theorem about order and signs of determinants, that says the determinant then of 0, 0, 1, V1, V2, 0, W1, W2, 0 is positive. Right, so this is that R3 theorem. Okay. And let's see here. What's that determinant? I can calculate that determinant. Just go across the top, the submatrices and all that. And the determinant is V1W2 minus V2W1 is greater than 0. Well, wait a minute. But I mean, now I can. This is a fact about algebra. I can forget about the geometric context that this came from. The fact that this came from a discussion of stuff happening in R3. This is exactly a 2x2 determinant. So I could say, well, that means that the determinant of this little matrix, V1, V2, W1, W2, is greater than 0. So altogether, counterclockwise order means that this determinant's positive. And this argument goes backwards. If the determinant's positive, that means that's true. Well, this is just that determinant, so that's positive. We have a fact that says that the determinant's positive. That means that these three row vectors are in right-hand order. And as we discussed in the previous exercise, that means that these two vectors are in counterclockwise order. So all these arrows go backwards also. And you can make a similar argument if it's clockwise order. This will be left hand, and that'll be a negative, etc.